The 4.1 is extrema on an interval. Sorry. So let me give you the definition of extrema first. So number one, f of c is the minimum of f on I when f of c is less than or equal to f of x for all x in I. Number two, f of c is the maximum of f on I when f of c is greater than or equal to f of x for all x in I. Quick note, the minimum or maximum of a function on an interval is also called absolute max or absolute minimum, also called global max or minimum. Just to make sure we get the, what's it called? All the terms out of the way, because they're going to be using this in the homework and the book. So this is what all means. Theorem 4.1. If f is continuous on a closed interval, a b, then f has both a minimum and a maximum. Let's get all the definitions out of the way first. It's quite a few. A lot of theory because there's a whole new application of derivatives. Critical number. So definition of a critical number that FB defined at C if f prime of C is equal to 0 or if f prime is not differentiable at C, then C is a critical number. So basically, in just normal language, if there's a value that makes the derivative 0, that's a critical number. If there's a value that is undefined inside the derivative, but not the original, that's also a critical number. Okay, and those critical numbers have the potential to be maximums or minimums or extrema. Okay. Theorem 4.2. If f has a relative minimum or relative max at x equals c, then c is a critical number of f. Let me slow down for a second and put my phone on the charger. 1 moment. Okay. Okay, so that's the theory. Let's get to the guidelines on how to do this stuff. How to find extrema. You guys finished on this page?
No, I just have the then 4.2. That's where I'm at.
4.2? Okay. Oh wait. I have plenty of time.
In the meanwhile, can you say again what you said, that part where you said in regular words or in regular language or?
Critical number. So when I try to find critical number, I'm just in plain English, right? Any value that makes your derivative 0 is a critical number. Also, if that number is defined in f, but not defined in the derivative, it's also a critical number. So those are the two things that make it critical.
Excuse me, sir.
Mhm.
I just got back from driving. Did I miss too much?
No, we just missed the introduction, and we're gonna explain how this works in just a second. We
This is
defined 4.1. Yeah, we're starting chapter 4.
Okay.
This is test 3 material, the
Okay.
beginning of it. Yeah, I'm sorry you missed that message. That stinks.
It's all right. It happens, right?
Yeah, it does.
Okay.
I thought about reminding everyone a second time. I was like, yeah, I'm sure they saw it. It's fine.
No, it's all right.
Should have listened to my gut there.
I live pretty close to the school, so it's not like a terribly far drive.
Oh, cool. That's good.
Yeah. Oh,
So what we're going to be doing in this section is you're going to be given a function. The homework is going to start out by telling you find the critical numbers. That's the first couple of problems. Then after that, they're going to tell you find the absolute extrema, which is maximums and minimums. You know, like a parabola. It was if it was opening down, there was a maximum, right? All those peaks and valleys that we talked about in college algebra.
yeah.
All those are going to be called or considered to be extrema, max and mins.
Okay.
And those numbers, those extremas or maximums or minimums happen at critical numbers. So that's why we want to find the critical numbers. Okay, so let me show you. Let me write down the guidelines on how to do this.
Oh, could I see the top of that front page real quick?
Yeah,
I'm
yeah,
sorry. I'll just take a quick picture with my phone and then I can write the notes later.
sure.
Thank you, sir.
You want the bottom half too? Or just get that?
I actually got the bottom one, I think. Hold on. Could I see the
sorry.
top again?
Yeah, I didn't catch that.
Okay. Do I have that part? Yeah, I've got that. Thank you, sir.
Okay. You got the bottom, you said?
Yeah.
Guidelines for finding extrema on a closed interval. So if the question tells you it's closed, meaning it's not they're only looking at one section of the function, like they're saying, tell me the maximum value between 0 to 5. Then these are the steps that you would follow because that's considered to be closed. Open meaning anywhere on the function, negative infinity to infinity, anywhere on the domain of the function. Okay. So number one, first step you do when you have a question like that is find the critical numbers of f. That's what you got to do. And of course, I'll show you how to do that in a moment. Number 2, evaluate f at each critical number in AB. Number 3, evaluate f at each endpoint of AB. Then, number 4, the least or smallest of these values is the min, the minimum. The greatest or largest of these values is the max. Okay, so that's what you'll be doing if it's closed. All right, so first let's figure out, how do you find critical numbers? All right, I'll explain what they are. So let's find out how you find them. This is problem 5 from the homework. Find the critical numbers of the functions. I should say function. F of x equals x to the 4th minus 8x cubed. So step 1, find the derivative. So f prime will be this guy, right? Step 2, set f the derivative, f prime, equal to 0 and solve for x. That's how you find the critical numbers. So here's the derivative equal to 0. Factor out 4x squared, and that gives us x minus 6. So 4x squared equals 0. X minus 6 equals 0. So critical numbers are 0 and 6. Excuse me. And that's it. That's how you find critical numbers. You take a derivative, set it to 0, solve for x. Any questions on these steps here? Okay. So the first few questions will be just finding those.
So did you just square root the 24 minus 24x squared?
No, I just factored 4x squared out of both here.
Those is like another couple.
Oh, okay, gotcha.
Then you set each one to 0, and then you're gonna solve for this. You get this. Okay, so now let's do a question where it is closed and we need to find the maximums and minimums. Okay, so any questions on the first example?
So still, how did you come up with the 0 and the 6 as the critical numbers? Because the 4 you can't do anything with, or because
Well,
it's not.
if you move the 6 over, you get x equal to 6, right?
Mm-hmm.
And then the only way this will be 0 is when x is 0. That's where
Okay.
these come from. Does that answer your question or no?
Yeah. So is 0 always going to be the critical number, or no?
Not always. Sometimes it could factor like a quadratic, right? And have x plus 2, x minus 3. Or depends on the function.
Okay, I get it. Because you said the greatest and the least, or the biggest and the smallest numbers, right?
Well, we're going to get to the next example. On this one, all we're doing is finding out what the critical numbers are. Later, we're going to, on the next example, we're going to use them to do something.
All right.
Okay.
Are you there?
You guys cool on this page?
Yes, sir.
So let's do problem 9, where it's a closed type. And they want us to actually do some work, like use this critical number stuff. So find the absolute extrema of the function on the closed interval. So closed interval, it's closed on this interval. So this function only exists from -1 to 6. After that, we don't care. And when they say the words absolute extremum, that means maximum or minimum, the biggest and the smallest values, right? So we need a so step 1 to do this. Remember the guideline said, find the critical numbers. But we first need to get the derivative. So the first derivative will be 3x squared minus 3x. Step 2, set f prime to 0. And find the critical numbers by solving for that. So 3x squared minus 3x equals to 0. Factor 3x. That gives us x minus 3 equal to 0. So 3x equals 0, x minus 3 equals 0. That gives me this. Zero and 3. Step 3. Plug in the criticals and the endpoints into F, the original. Okay, so the numbers we're going to plug in x equals 0, 3, -1, 6. So f of 0 is equal to 0 cubed minus 3/2 times 0 squared. 0. F of 3 would be 3 cubed minus 3/2 times 3 squared. 3 times 3 times 3, what is that? 27, right? That should be a 3 up here. Minus 27 over 2. That's the ugliest 3 ever. Okay. So this would be 50, no, 27 over 2. We subtract those fractions. This is roughly 13.5. Okay. F of -1, that would be -1 cubed minus 3/2 times -1 squared, which would be -1 plus 3/2, which is 1/2. Okay, so I tested these 3. Now let's test 6. F of 6, that will be 6 cubed minus 3/2 times 6 squared, which will be 6 cubed. Yeah. Minus 108 divided by 2 minus 54. 162. So we got the critical numbers in there. We got the endpoints. What is the smallest value?
Zero.
It looks like it, right? Let me double check everything though. Oh, that's a mistake right here. That's not going to be 0. -1 minus 3/2, that's going to be -5/2. Okay. So this is the smallest now. And the biggest are these. So minimum at minimum at -1. I plugged in -1 and got -5/2. Maximum at, I plugged in 6 and got 162. So we found the absolute minimums and absolute maximums.
So like, does that mean that if I were to graph the original equation and I would just look at the graph in that interval of those X values, -1 and 6, I would see my minimum point would be -1, -5/2, and the highest point that I would see would be 6, 162. Those would be the highest coordinates.
Yeah, exactly. So you're able to find it without using any kind of graphing utility. And actually a lot of those programs use this in the background. But yeah, you're right. Let's go ahead and graph it. It's a good idea. All right. Okay, so I'm gonna let two solid lines equal to the lowest point and the highest point. So we're closing it off here, right? The blue and green. So the lowest is right there, which is what we found, right? That's -5/2, by the way. The other one is up here. Hard to see because I need to change the scale. 6/162. So for Y, I want to see. Let's see if I can scale it better. There we go. That looks a little pretty, right?
Wasn't there a way you could type multiple, like you could type the 0, the 1, the 0, the 3, the -1, and the 6 all in the same calculation, and it would give you all the answers at the same time?
Like, what do you mean on what?
Like on, instead of typing the same thing, and oh my god, my brain's not working anymore. The same, but just changing the number, you could type it in like in either like at the bracket or the little curly bracket.
Like to plot the point itself.
No, like the 83. You could type in the
Oh, on the 83. Yeah, on 83 you can tell it to, an 84. You can graph it and tell it to give you a maximum or minimum.
no, like I mean like in the actual calculator, like the calculator part, like you could type in all the options you wanted it to calculate on the same.
Oh, like an output.
Yeah. Instead of typing the same formula over and over again, just changing the number.
No, not. I mean, you might be thinking of like maybe stats or something. If you were to use the graphing utility to find a maximum or minimum, you would have to. Well, I guess I can show you. It wouldn't be this. You would have to redo this over and over again. So let's say I had
You're talking about when we use that store function, Rebecca?
No, not in the store. Like you could use like I think the curly like in the just regular like actual calculator part of it. Not in the graphing part or anything, but like in the actual calculator part. I think you could do like the curly bracket and you could type in 0, 3, -1, 6 and type in the rest of the formula that you wanted or like the rest of the
Oh, you're saying like input all these and define your F.
yeah, and then it would give you all the answers.
It would give you these outputs. I mean, I'm sure that might exist. I haven't tried that, but yeah, you could get all these little numbers here, most
I just
likely.
remember how to do it.
You'd probably have to define F and figure out how to plug them all in at the same time.
I think it was the curly bracket.
I don't know. Never done it before.
Make sure to do all these.
But that seems like something that would be in here. That doesn't sound like too crazy for this calculator. Because you can define formulas, so why not run values through that formula? I want to say 9% sure you can do that. But I mean, that's not the hard part though. But what matters is you understand what's going on. As long as that makes sense, you can use that if you like. But anyway, any questions on the idea? Does it make sense? Do you see what we're doing?
Yes, sir.
Okay. That's 4.1. Let's see, maybe we could do another example. Yeah, I mean, it's the same thing over and over again. I think we should move on because it's going to be the same. It's going to get more. It's going to repeat itself in the next section.
It's my laziness coming in handy. It's the little curly bracket.
Yeah, show me when you figure it out. That sounds
that's
sounds cool.
Well, it's just a little, you do the little curly Q bracket. It's not the straight bracket,
Mhm.
but it's just a little curly bracket and it'll give you all your answers.
But you got to plug in. You got to create the F right somewhere.
Well, it's just so when you plug in, well, you've already got the formula or not. I don't know why I keep calling it a formula.
The function.
Yeah, the function.
Mhm.
So you're just plugging in all your F's that you got from getting the minimums and maximums. So you still got to do that part, but this is just to stop you from typing it into the calculator 20 million times.
Yeah. Oh, I see. I mean, yeah, you could always just toggle up as well and just replace the values. But if it's an ugly function, your way sounds way better.
Yeah, so my laziness comes in handy sometimes.
But then I would miss the chance of making a careless mistake that would throw the whole problem off.
That's funny. So 4.2, I'm gonna skip 4.2. Just it's only 3 questions on the homework, so just watch the video and do that later. I'm probably not gonna test you on that. 4.3 is what matters, and that's more involved. So let's go to 4.3. So it's basically gonna expand what we just did more in depth. All right, 4.3 is increasing and decreasing functions and the first derivative test. So real quick, before we start, just want you to think about this idea. I'm hoping at this point that you remember that derivatives, when you plug in values into a derivative, they give you slopes, right? We've been saying that for a while. So if you have a function, let's say, let's pick a different one. Can't see the buttons. That's not what I want. I think that'll have to do. I think it'd be better if I just draw it myself. Yeah, we'll do that. So do you remember, right? If you have a function like this, that all the derivative values over here are increasing, right? Then up here, it would be 0 because the tangent would be horizontal. Then going down here, we would be negative, and then again, horizontal. And then right after the horizontal, it switches to negative to positive. So you see how whenever it goes from plus to minus, there is a point in the middle called the critical number, called the maximum, the extrema. So that's the idea. So if you can figure out what's happening around a critical number, and you notice a change of sign from plus to minus, or plus or minus to plus, then you have a extrema value. So that's essentially what the first derivative test is going to do for you. You're going to test around it. You're going to, well, I guess you're going to first find the critical numbers of some f, test around it with the derivative, and then determine, is that critical number a maximum or a minimum? That's it. That makes sense?
And do we always look at it in direction from left to right, like in that recall?
Yeah, it'd be left to right always. So if it's plus minus, that's a maximum. If it's minus plus, that is a minimum.
Sir, I'm trying to write notes for this. So would I say that we are testing to see if we're testing things on either side of a point to see if that point between those two things is a minimum or a maximum?
Yeah,
Is that
but
how I read
yeah,
that?
that sounds right. I would just add that that point is called a critical number.
Okay, so,
You're testing around a critical number to determine if it is a minimum or a maximum. We will call it, but it could be a local minimum. It could be an absolute maximum. It could be like, for example, this function here keeps going forever, right?
yeah,
So this is technically not the maximum because it explodes over here. But we could call this a local max or local minimum. And if we were to close it like we did in chapter 4.1, then these would become potential maxes or minimums. But yeah, but that's what you should do. You're right. Test around the critical number.
thank you.
So let's do an example and show you how it works. Identify the open intervals on which the function is increasing or decreasing. So the first few problems on the homework, they're not asking about all that just yet. They just want to see, can you determine where we're increasing or decreasing? Like, do you remember how to do that? So let's practice. So here's some G function. Now, if we were to graph that guy, we could tell right away, right? So here is the critical number. It is a minimum, but we're not talking about that right now. From left to right, we are decreasing all the way up until here. So from negative infinity up until 3, we are decreasing. So that's the answer for the decreasing part. Then from 3 to infinity, we are increasing. Do you guys see that? So left
Yes,
to
sir.
right.
Yeah, you weren't the computer in my mind, you were not the computer savvy person in the way that
So remember I told you picture like a little car, right? If the headlights are pointing downward, decreasing. As soon as it turns the corner, the lights are pointing up, increasing. And that turn happens at a critical number. Anyway, so we're going to find out, we're going to do the work to find that, not just look at a graph, because you need to be able to do this on paper. So step 1, of course, is find the derivative. So G prime will be 2x minus 6. Step 2, find the critical numbers.
So in this case, it would be just factoring out the 2, and so x minus 3.
Yeah, pretty much. So set f prime to 0. The 2x minus 6 equal to 0. Factor the 2 like you said. X equals 3, right? That's my critical number. Okay. And we already knew that, right? When we graphed it, we did say 3, didn't we? So step 3. One second. Use the first derivative. Test to test around the critical number to determine if it determine if it is a max / minimum, and to find the intervals of increasing / decreasing. So even though they didn't ask for max and min, you would go about finding that the same way. So we might as well just do it, you know. We'll say this is part A or something. Okay, so draw you a picture here. So here is the special number, the critical number. Pick any number you want below as your test point. I'm going to choose 0. So plug in 0 into the derivative. What do you get? Is it negative or positive?
Negative.
Negative.
Negative, right? So that tells us that we are increasing, decreasing all the way up until this point. Now, we don't know if we continue to decrease or if we begin to increase after. So pick another number right after. Choose an easy one. 4. Derivative at 4. That's positive, right? So it begins to increase. So this tells us we have a minimum at 3. It also tells us that we are decreasing from negative infinity all the way until the critical number. That is the first derivative test. You see how it works.
So what I thought critical numbers, I thought they were where we have like peaks and valleys or something.
Mhm.
So we can have, how do we have a peak that continues to go negative?
No, it stops right at this point. It begins to increase. So before the valley, we're going down, and then after the valley, we're going up.
I guess because I heard you say before we plugged in the 4, you said that it decreases all the way till it gets to 3, and then we don't know what's going to happen after that. But if it's a peak, doesn't it automatically go up?
Well, we got to test. We don't know if it goes up or not. I mean, we knew because we looked at the graph, right? But we're assuming we don't have a graph right now. So
Yes, I'm saying is that if it decreases, how can 3 be a peak?
it's not a peak.
I mean, a critical number. Oh, so critical numbers aren't always at the peak, at the absolute minimum or absolute max?
Yeah, well, to answer your question, no, it's not always going to be at a peak or valley. This is a valley though. So I am decreasing up until 3, and then I'm increasing. So that gives me that parabolic shape of a valley here. So because the derivative at 4 is positive, I increase after the 3. The derivative at 0 is negative, so I'm decreasing before the critical number.
Yeah, that's what I'm saying. I think I just misunderstood the definition of a critical number.
A critical number is a potential maximum or minimum. It's basically a potential extrema.
Yeah, potential. There it is.
Mhm. It's not guaranteed. That's why we're testing. So the first derivative test tells you and confirms it, which one it is, or if it's either one. It could be neither. We're in a space on this page though, so are you guys cool on this one? Let me finish it up on the next one. Okay. So continue this on the next page here. I'm going to redo that step right there. Also, I called it F by accident. It was actually a G, wasn't it? My mistake. Okay, so let me write you another note here. Choose any number below and above a critical number and plug it in into the derivative. So I chose G prime of 0 because it was easy. I got a -6. G prime of 4, that gave us a 2. And that's when we determined, we had to redraw that picture for you so it's all on the same page. 0 was negative, decreasing. Then over here we were at 4, we were positive, so we begin to increase. This shows us a minimum at 3. X equals 3. This also tells us that we are decreasing. That's what they didn't ask about this, but it's a consequence of all that. We're decreasing from negative infinity until 3. We are increasing from 3 till infinity. So this is what they asked for. But you see how the first derivative test gives you this and tells you about a minimum. But the first few questions will not ask you about minimum. And if we go back to the graph, right, we knew all this already. Here's 3. We were decreasing from negative infinity all the way till 3. And then after 3, we are increasing. And we can see that it is a valley, right? It's a minimum. In this case, it turns out to be a global minimum. It is the lowest point of the function. Any questions on this problem? This is number 1. See, all they wanted was this.
And so I forgot about the brackets, right? The brackets mean what, included or not?
Yeah, bracket means you're including it. So parentheses is saying on this one, right? It's saying that we're increasing right after 3. We're decreasing right before 3. We're not including 3.
So even though 3 is part of a point in this, because of what it's asking, we wouldn't use the bracket.
Well, think
Like if it
about
was
it.
just asking us for the domain and range, we would be using brackets, but because it's not asking us that, we use parentheses.
Well, we use brackets when we are going to include the point. We're not increasing at 3, so we do not include it. Right? Because remember, right at that point, if we go back to the graph, we have a horizontal tangent line right here. So that's neither increasing nor decreasing. Before we're decreasing, right? But right there, we're neither one. Right after, we're increasing. So we can't put a bracket because of that. Any other questions on number 1?
Nope, I think this makes the most sense out of everything else in the class.
Yeah, because we're applying all that theory we've been learning, right? To something. We're using it finally. Everything else was all just how do you just techniques on finding derivatives over and over again. And now we're doing something with it.
Piloting shit for me to be a pilot.
And you're gonna do a bunch of stuff with it in engineering, so maximums and minimums are pretty important, right? Because they could be maximum force, maximum profit, could be all kinds of stuff.
How much energy can I apply to this resistor before I blow it up?
Just like
Yeah.
the United States military.
It's true, maximum resistance. It's a true story.
I keep telling one of them to let me blow up something. Just let me get it out of my system.
Get them to train
Yeah, I
us.
remember one of my professors, he was old school. He told me back in his day,
Openly.
all the engineers would blow stuff up, break things to test it, because that's how they did it. But nowadays we have computers, so everything's done with simulation now, so it's not nearly as fun as it used to be.
And see, I did blow up a simulation and it still wasn't as fun. It made me laugh because I have techs coming after me with torches and pitchforks, but
It's
still not as fun.
hilarious. No, it's like he used to work at Los Alamos, and he'd tell me all these stories about blowing weird things up and doing crazy stuff. But now we just simulate.
But some of the engine control modules I see come back that are blown up on the inside, I'm like, come on, let's recreate that. See if we can make it do it again.
So
What do they say?
They tell me no.
It's no fun.
I
doing
I
that,
get told no a lot.
so,
Oh,
They're
well,
probably looking out for my safety, to be fair, but
how
true.
also do
I think it'd be a lot of fun.
That makes sense. Okay. So this one will do everything. We'll do the maximum, minimum, critical numbers, increasing, decreasing all together. So first thing we gotta do is find the critical numbers, right? So in order to do so, you gotta find the derivative and set it to 0. So set this to 0. And there's my critical number.
So when the number you factor out doesn't have an X, it's just one critical number, right?
Yeah, I mean, if you try to solve this 2 is not going to do anything, right? Because you could divide the 2 out, and it'll be gone forever.
Yeah.
And then
Okay.
you move the 2 over, you get this. But yeah, if there was an X there, then you'd have to set that to 0 as well. Okay. So it looks like we only have one critical number. So let's start testing. So test around X equal to 2. Pick any number you want. I always recommend 0 if it's an option, because it's easy. So the derivative at 0 is negative. The derivative at 3 is positive. Negative, positive, decreasing, and then increasing. I didn't show the work here. You guys see where these numbers came from? Or how this happened? Okay. So we can answer all kinds of questions, right? Where are we increasing from? What is the interval? Where are we decreasing?
So for increasing, or can I answer? I'm sorry.
Yeah, please.
Sure. So for increasing, it should be parentheses 2, comma, infinity, positive infinity.
Mhm.
And for decreasing, it should be parentheses negative infinity to 2. So
Yeah. And is this a minimum or is it a maximum?
it's a minimum, but I don't know if it's the local or not.
True. So it is a parabola, right? Is it opening up or down?
Oh,
Up. So it should have a global minimum. It should not have a maximum. Because it keeps going up. Right? So minimum would be at 2 something. So in order to find that value, you got to plug in 2. So they didn't ask for in part A, but I went ahead and did everything. Because it kind of happens all at once anyway. Are there any questions on this? Just straightforward. Okay, this doing that has multiple critical numbers. It'll be the exact same process, but you'll have to do tests between critical numbers after and before. So you'll have what's it called? Multiple minimums or maximums. You guys cool on this page?
Yeah, sure.
Sample 3. Yeah. This is problem 9. Consider this function 5 minus x times x plus 1 squared. So part A, we'll find the critical numbers again. Try to remember to write part B. So we gotta find the derivative and set it to 0. Those were the steps. So the derivative is gonna be, what type of rule are we gonna use? You remember?
Product.
Yeah, it's gotta be a product, right? So derivative of the first piece times the second piece plus first piece times the derivative of the second piece. Let's put a bracket on it. Okay. So that'll be -1 times x plus 1 squared plus 5 minus x times 2 times 5 minus x. Yep, that looks good, right? Wait, what?
5, where are you getting the 5 from?
where that came from. Okay. So we could multiply all this out. Although it looks like I could factor stuff, right? I see x plus 1 in common. So that would leave me with 2, put a bracket here, times 5 minus x, right, this piece, minus one of those. Is that weird? Multiply the 2. You don't have to do it this way. I just thought it'd be easier. Negative 3x plus 9. So that way it's already factored. Because as soon as I see something I could factor, I figure I can put it back to a compact form instead of multiplying all this out and doing more work. So you can just set this to 0. A lot easier. If it's factored, you can already find the x's. See what I mean? So here are the critical numbers. Part B, find the intervals for increasing / decreasing. So here's -1, here's 3. I'm going to pick 0 in the middle. I'm going to pick 4. I'm going to pick, I don't know, -2, I guess. Okay. So plug those numbers into the derivative. The derivative at -2 would give me -2 plus 1 times -3 times -2 plus 9. So that'll be -3 times $15. It doesn't really matter what the number is. What matters is it going to be negative or not? This is negative, this is positive, so negative. Derivative at 0. That'll give me 1 times 9, positive. Now to test after 3. That'll be 4 plus 1 times -3 times 4 plus 9. This is positive, and this is -12 plus 9, which is negative. So negative. Okay, so we are decreasing and then suddenly increasing. And then we're decreasing, increasing. No, actually, that's not how you draw it. My bad. It'd be like this. It'd be increasing all the way, and then it starts to come down. of this. So we have a minimum, maximum. There we go. Okay, so the answer for part B, where are we decreasing? Make some space.
Are you waiting for us to answer?
Mhm.
Oh. I guess it'd be decreasing from what, negative infinity to -1,
Yeah.
and then we put some kind of symbol, right? Union or something like that
Mhm.
from 3, right? You the parentheses 3 to positive infinity.
Yeah.
Just infinity, I guess.
Right.
Put another parenthesis.
Yeah, that's it. And increasing,
From -1 to 3.
-1 to 3. Yeah, that's it. That's part B. Part C will be max and minimums. Amount of space though. All right, you guys go on this page. Okay. So maximum is at three something, right? Minimum.
Is what, 32?
Yeah, it'd be -1, right? For this one. What'd you get for max? We gotta plug it into the original, right? Oh. It's a 0, right? Yeah.
I got 32 for the max. Oh, wait, you already did that one.
Yeah, minimum I got 0. Did you get the 0 too?
Zero.
Cool.
I want like the
It's just we're paying
the auto
attention where you
prompts.
actually put in the calculator because it's handy. Because the first time I did it, I got 240. I was like, wait, there's something wrong there.
Yeah, just double check yourself. It's always good. It's not too bad so far, right? Making sense. Nope. All right, we're almost out of time. So you guys have any questions about chapter 4?
None so far.
Just, did you say you're not gonna test this on 4.2?
No, not gonna test you on that. It's good theory to go over and read about. So I kept the 3 questions in there, but it's not I'm not gonna ask about it. I would just like you to look over the theorem, Rolle's theorem. All right, guys. So I moved the exam to I think next Wednesday, or maybe even further than that. I forget. Let me double check.
Exam 2?
Yeah.
Okay, thank you.
Exam 2. Yeah, I moved it all the way to April 6th, just in case. I mean, I think that's too much time, but if you need it, feel free to use it. I would prefer you take it as soon as possible and move on to chapter 4, but I'll let you decide that on your own. To get that done as soon as you can, closes on the 6th of April. We'll have exam 3 probably after 4.7, 4.8. So probably not anytime soon, but I'll probably finish chapter 4 next week or beginning of April. And then we'll start reviewing probably that week of the 4th at the earliest. Okay.
Did you see what I was talking about on the whole practice another thing?
Oh, let me see. You want to show me the screen?
Look, there you go. Nope, that worked. Oh, there we go.
Okay.
So the little where it says practice another.
Practice another. Hold on a sec. Oh, right there. Yeah. Is that turned off, or is that what you're saying?
Yeah, he doesn't do anything. I don't know if you got the.
Is it because it's closed? Was it active when the homework was open?
I have no idea.
Look for something that's currently open real quick.
Whoops. Ah, there we go. Yeah, it's not there.
Yeah, it's not there at all, right?
Yeah, it's not there at all.
Weird. Why does the other one have it? Were you able to do it when they were open, or do you know?